One day, one problem. Day 2. Today we're going to identify an unknown organic compound. And to do that, we'll use 3 different spectroscopic techniques, like detectives collecting clues. Our first clue is IR spectroscopy. But what even is that? Every organic compound is made up of different functional groups. Think of functional group as the building blocks that determine how a molecule behaves. For example, alcohol have an OH group, ketones have a carbonyl group, and alkanes have an alkyl group. IR spectroscopy works by shining infrared light onto the molecule. If the light has just the right amount of energy, a bond absorbs it and starts vibrating. Different bonds vibrate at different energies. Now let's look at our spectrum. We see 2 important peaks. One at 1730, I'm talking about fatty WAP. Another around 2964. A peak near 1730 usually means we have carbonyl group. And 2964 tells us there are alkyl CH bonds. So now we know our compound contains a carbonyl and some alkyl chains. That narrows the possibilities down quite a bit. At this point, it's most likely a ketone or an aldehyde. But which one? That's where mass spectrometry comes in. Mass spectrometry basically smashes molecules into smaller pieces called fragments. So the ampere Z value is usually just the fragment's molecular mass. Our biggest peak, the base peak, is at 43. Since we already know our molecule contains a carbonyl group, let's see what fragment weighs 43. Turns out, it's actually the acetyl cation. Another important peak appears at 71. This fragment commonly corresponds to pentylium ion. Finally, the molecular ion appears at 114. This tells us the entire molecule has a molecular mass of 114. And would you look at that? Everything matches. We then use DBE for the degree of unsaturation and proton NMR to confirm where the hydrogens are. So now we draw the structure, give it a name, and boom shakalaka! Our unknown compound is 4-heptanone. That's exactly how chemists solve molecular mysteries. One day, one problem. See you tomorrow.